Okay, so for section 2, problem 2, we have Marcus is at a shooting range firing bullets at bales of hay with targets on them. He uses bullets with a mass of 250 grams, and the bullets travel at 450 meters per second when fired. A. Calculate the momentum of a bullet after it has been fired from the gun. So for letter A, all we have to do is remember the definition of momentum, which is the mass multiplied by the velocity. In this case, the mass of the bullet is 0.25 kilograms, and the velocity initial is 450 meters per second. Alright, if you take this multiplication, that is 112.50 kilograms meters over second. That is for letter A. Then for letter B, Marcus hits the target. The bullet lodges inside the bale of hay in a time of 0.1 seconds. The bale of hay has a mass of 70 kilograms. Calculate the speed of the bale of hay just after it has been hit. So the information that this problem is telling me is that for this period of time of 0.1 seconds, this is what happens to the two objects. They are colliding and they are together. So for this period of time, we will consider the mass as the sum of both the masses, the mass of the bullet plus the mass of the bale of hay. And also for solving letter B, we must remember conservation of momentum. Conservation of momentum tells me that the momentum before the collision has to remain the same before and after the collision. So from letter A, I found the momentum before the collision, which is this. And because of conservation of momentum, momentum before and momentum after has to be that. Okay? And by definition, momentum after is the mass after multiplied by the velocity. So the mass after is the sum of 0.25 from the bullet and 70 from the bale of hay multiplied by velocity. Okay, so I get this equation, and from here I can solve for V. If I solve for V here, I will get this fraction, 112.50 over 70.25. And here in V, this I'm not considering initial velocity because the bale of hay doesn't have motion before colliding. So here I can only worry about final velocity. And that velocity is 1.60. Okay, that is the velocity right after it has been hit. Letter C. Now calculate the force that the bullet exerted on the bale of hay. For letter C, you must remember Newton's second law in terms of momentum, which relates what is the delta P over delta T. In this case, we want to identify what is the change in momentum over the time. And again, here I'm looking into what happened to the bale of hay only. So, what is the momentum of the bale of hay final? Well, that is the mass of the bale of hay multiplied by its velocity. Okay, here. And I know the velocity from letter B. It's here. So what I have to do here is multiply the velocity by the mass, which is 70. And there is no initial momentum in the bale of hay since it was not in motion. So by taking this division, I get 1120 Newton. That is the force exerted on the bale of hay. And here notice that I only considered the bale of hay because that's I'm finding the force exerted on the bale of hay. Okay, there is an external force, so there is not a force that is being applied in both the bullet and the bale of hay. There is only a force that is being applied from the bullet to the bale of hay. So that's why I'm taking only mass of the bale of hay here, and that is 120. So what do your answers to part B and C tell you about the subsequent motion of the bale of hay? So from these two answers, I know that the bale of hay will be moving at a speed of 1.6. So the bullet will impact on the bale of hay, making it move in the same direction that the bullet with a velocity of 1.6 meters per second. Okay, that's what we can tell from parts B and C.